Welcome to the complete setup and operation guide for the IND360 rate control from METTLER Toledo. Rate control from METTLER Toledo efficiently manages screw feeders, vibratory feeders, and pumps using advanced algorithms for accurate flow rates. Whenever you are installing, configuring, or troubleshooting IND360 rate control, this video will help you from wiring to adjusting our product to different materials and setups. A full manual on how to install IND360 rate control can be found at mt.com. Here on the video, you can see a typical feeder setup. Normally, it also includes an upper container or storage container for material storage. In our case, a refill will be done manually. A lower container, or in our case, this is a feeder, as you can see, or a source container, is for measurement where the weight sensor is installed. With the set target flow rate value, a rate control application adjusts its analog output to drive the feeder. The signal adjusts the feeder speed to match the desired flow rate. Digital input-output signals include start, stop, refill, and alarms, configurable via dial board. This link directly to PLC or signal devices. We strongly advise you to use our web interface for IND360 application and specifically for rate control to configure all application parameters and monitor data from the process. Detailed description on how to access it can be found in a separate video, and this web interface can be accessed via the service port IP. In order to check what discrete inputs and outputs have been already set, one can go to the home page first, where it's all displayed. And in order any changes needed to be made, one can go to the application section and then to discrete input-output, where you can arrange everything as you want. Before setting up rate control app itself, let's begin with unit and capacity setting and scale calibration. For that, we go to a scale section, to the capacity and increment section first, where we set primary units, capacity, and resolution of the scale. Then we can switch to the calibration section, and you perform a classic and very standard calibration procedure for the scale, meaning that you need to adjust the geocode as well as the zero. And the zero in this case is set with the feeder on the scale or on the weighing sensor to cancel the signal from the feeder. Afterwards, we can adjust the span with the test load. In my case, it's been already done. We used 5 kilograms as a span adjustment weight. And then you are good to go. It's important to mention the influence of the scale resolution on the further process for rate control application. If your scale resolution is not high enough, you will constantly get an error that your material flow was not detected. So the first thing when you get such an error message is to make sure that you have enough resolution for your material flow. Now we can switch to functionality enabled by rate control app. For that, we go to the application sections and to the rate control. And this whole process starts with a system identification step. System identification feature enables automatic tuning of PI values, flow limits, and signal smoothing to achieve optimal feeder performance. In this step, rate control app learn about your system by running through 6 steps in order to identify perfect parameters for your setup. In every step, algorithm increases control variable that corresponds to a motor speed. Ideally, to start, for this system identification step, you just need to set the control variable safety limit and make sure that there is enough material in the feeder to complete this step. Our recommendation is don't set control variable adjustment range too wide because you will use too much material. So for this test, I will use from 10% to 50% values. Then I will be confident enough that I have enough material in my feeder to complete the system identification step. I just performed the refill of my feeder, so I know that I have enough material inside of it. And I also adjusted a lower limit for my control variable as 10, because for motors normally it's very complex to keep any control variable below 10. So we make it easy for our system identification step. Now we are good to go. Another useful information is, in order to monitor your data, you can use a tool called Signal Analyzer, where you can display your current flow rate, your current control variable, as well as a target flow rate and a feeding level. And it's a very nice tool, not only for monitoring, which is great, you can detect any abnormalities in your setup very quickly, and also you can download the backup file that are extremely useful for further troubleshooting. So at the moment, Signal Analyzer is already running. Therefore, we can send a command to start. On the screen of the terminal, you have all useful information about current step that we are performing. You can see that currently we are in system identification mode. You can also see number of steps already completed as a part of system identification, and we see a total number of steps. You can also see control variable number that was set by our system, as well as the total weight of the feeder and the current flow rate. It's important to mention that depending on material property and depending on geometry of your feeder, you may need to do some fine-tuning for the system identification mode. For instance, if your material is very fine or very sticky and the nozzle of your feeder is very long, it may take quite some time for the material to go out of your feeder. In such a situation, we recommend to run your feeder before running a system identification to make sure that the nozzle is filled with material. Then we switch back to the rate control application. And since our system identification has been completed successfully, we can switch from a system identification mode to a continuous mode set. You can see that the PI parameters as well as filter window length has been defined automatically. PID tuning mode is auto-tuning, meaning that during operation, during our continuous mode, both parameters will be automatically adjusted. A maximum flow rate being calculated as 140 kilos per hour. And we can set the target flow rate accordingly. So let's set it to 100 kilogram per hour. We switch to a signal analyzer back. We start another data file, and we can then run our continuous operational mode for our feeder. Be sure to set your target flow rate correctly. This target should correlate closely with the maximum flow rate defined during the system identification process to achieve optimal performance. And in the meantime, we are at 100 kilograms per hour, and we are quite stable on this target. In order to set a different target flow rate, you have to stop the ongoing process, and only after you will be allowed to change the target value for your continuous mode. Let's summarize what we've covered so far. The IND360 system provides powerful feature for precise feeder control with ability to auto-tune system behavior depending on the material, setup, and environment. The web interface and signal analyzer are essential tools that allow you to monitor, adjust, and optimize your process in real time, ensuring smooth and stable operation. We strongly encourage you to regularly back up your settings and store your process data. This practice simplifies troubleshooting and helps maintain consistent performance over time. For additional support, please visit our support links or contact our expert team who are ready to assist you. Thank you for your attention.